Hello and welcome back to Continuous Integration with Jenkins by Edureka. This is module 5th of this video series in which we are going to talk about implementing automated testing. The objectives of this video would be to first of all understand what exactly automated testing is all about. Then we will see how to run the automated unit and integration tests using Jenkins. We will talk about configuring test reports in Jenkins. We'll see how to display the test results. If needed, how do we ignore these tests for a particular build? Then we will talk about automated acceptance tests using JMeter. So with that, let's get started. First of all, let's try and understand what exactly automated testing is all about. Continuous integration as a principle, or CI, without automated tests is just an improvement on automatically scheduled builds. So testing or automated testing is one of the most important and most crucial components of overall CI/CD pipeline. Often it is one of the most neglected aspects of overall when we talk about continuous integration, continuous delivery, or continuous deployment. So using automated tests, one can determine if a particular build is ready to proceed to the next stage in the build process or not. So how it works is that there will be a series of tests going on for a particular build, and all of these tests they have to pass in order for the code to proceed to the next step. If any one of the tests is not passed, then the code will be sent back, or the results will be sent back to the developers and the stakeholders, and they have to fix it first, and then it has to be put in the pipeline again. This has to be repeated until all the tests are being passed by this code. So the best way to integrate automated tests is to write the tests first using either test-driven development approach or behavior-driven development techniques. So what are these two things we are talking about? So in recent times, they have gained a lot of popularity, both test-driven and behavior-driven. So what exactly they mean? So the first one, test-driven development, it can be defined as a programming practice that instructs developers to write new code only if an automated test has failed. So this avoids duplication of code. The primary goal of test-driven development is to make the code clearer, simple, and bug-free. So what happens in this approach, before you start writing the new code, you actually write the test cases first. So test-driven development starts with designing and developing tests for every small functionality of an application. So as I said, you first write the test. So first a test is developed which specifies and validates what exactly the code is going to do. And based on that, once you have the code written, you run that code against these tests. Typically, in the normal testing process, we first generate the code and then the test. Tests might fail since tests are developed even before the development. In order to pass the test, the development team has to develop and refactor the code. So refactoring a code would mean that changing some code without affecting its behavior. And the main goal of refactoring is to make sure or make the code pass those tests. Now that brings us to the second concept, which is behavior-driven development. Now BDD is a software development approach that has evolved from test-driven development, or TDD. It differs by being written in a shared language first of all. So this helps in improving the communication between tech and non-tech teams and stakeholders. Now, important thing to understand is that in both these development approaches, tests are written ahead of the code. But in behavior-driven development, or BDD, tests are more user-focused and based on the system's behavior. Now, why BDD? Test-driven development works satisfactorily as long as the business owner is familiar with the unit testing framework which is being used and the technical skills are strong enough for the person, which is of course not always the case. Now, in these kind of circumstances, BDD has the advantage because the test cases can be written in a common language used by the stakeholders, such as, for example, English or close to English. Now, this access to clearer, low jargon communication is probably the biggest advantage to use BDD, making it possible for collaboration between the technical and non-technical teams to run with improved efficiency. Some of the important things to understand about BDD is that the requirements should be converted into user stories first, which can be defined to give you the concrete examples. And then each example should be a valid user scenario rather than just a test. So the focus is more towards the behavior of how your software is going to perform or going to behave, or rather how it is expected to behave. And then how close it is actually to the reality or to the desired behavior of your code. Whereas in terms of test-driven development, the main approach is, or the main aim of a developer is to make sure that the tests are being passed. Now, what exactly those tests are doing, that's not exactly a big concern for them, as long as they have the test and they are able to pass those tests. But in behavior-driven development, we actually focus more on how exactly the software is going to behave eventually. And that gives you, the development team or the customers, a much better user experience. So why Jenkins? Of course, we have already seen a lot of advantages of Jenkins when it comes to CI/CD pipeline. Now, this is a timeline kind of thing where if you talk about 2013, Jenkins automation can easily tell how long the tests have been taking to run over time. So this time it was only more about how much time it is going to take, especially if it is sequential testing. 2014, Jenkins has started display the details of a test failure. So when it used to fail, what exactly is the reason, the output around that was being shown. 2015, it started schedule the test to run at a specific time. So let's say you want to run only at a specific time of the day, let's say during the evenings or only on weekends. So those kind of things became possible after 2015 or around 2015. 2016, Jenkins displays the test result trends. So as you can see here, the trend is to making things better and better and better. So more and more functionalities are getting added in Jenkins to work with. Now, one of the common things which you can expect is that all these things are becoming possible because of better and better plugins in Jenkins. So for all these things, as you can expect, there would be some or the other plugin. And finally, in 2017, as you can see, Jenkins displays a summary of the test results and it can automatically trigger the test results. It can send the mails after the execution of the tests. So basically, this makes the life of an automation tester easy. The key features, as you can see, all these which helps you understand why Jenkins should be used or why Jenkins is heavily used for automation testing frameworks. So now we'll try and understand the individual components when it comes to testing. So testing reports and understanding the trends, publishing the reports and things like that. So again, configuring the test reports, it's not exactly very difficult as you can expect. You need to go to a job and then you go to configure. Maven is one of the key features, especially if you are working with a Java-based project. So this is how we do it. With Maven, you just need to click or put the goal as verify. Now Jenkins works fine with any of the JUnit compatible test reports. In fact, for Maven build jobs, you don't need to have any kind of a special configuration done in order to configure the test reports. For freestyle Jenkins jobs, we need to ensure that the build runs the test and need to tell Jenkins to publish JUnit test report. Once again, we need to make sure that this plugin is installed on our Jenkins instance. If it is not there, we just need to make sure it is installed, and we have seen already. If you are still not familiar how to do the plugin management, you can just go and check module 3 of this video series. Now, as you can see here, we are using this publish JUnit test result report, and you basically give the XML location where exactly the report is going to be saved. Of course, this will be under the post build actions and not under the build actions. So those were about the Java projects. For non-Java projects, we need to have JUnit plugin. This plugin basically helps Jenkins process to test reports from non-Java based projects. And once this plugin is installed, you can go in and configure this inside the post build actions section, which we have seen already. So you just need to check for the publish JUnit test result report checkbox and just select the JUnit. When the build job runs, Jenkins will convert these reports to JUnit reports so that they can be displayed in Jenkins. So this is one of the screens, how it looks like if you are using JUnit test result report plugin in Jenkins. So when it comes to displaying the test result, so Jenkins' main job is to detect and report the build failures. It will distinguish between failed builds and unstable builds. So as you can expect, a failed build is basically the tests have been broken. The tests have been failed basically, and you don't have the build step gone ahead completely successfully. So that the software build has not gone successfully. So that's where it has been failed. When it comes to unstable build, so any unstable build is a build that doesn't meet all the quality aspects. One of the good examples would be where the jobs have run with some warnings. Not exactly a failure, but with warnings. So those kind of builds you can categorize as unstable builds. So Jenkins will show a graph of the test results for the builds that were executed. You can go to the detailed test results and you can just click on the graph to get the more information. So again, and for each of the builds, you will have actually the details and you can go and check it out. So for each job, you will have multiple builds, and for each build, you will have the test results shown. So you will have specific test results for each of the build. And all of these combined will be inside a project. So further, when we talk about displaying the test results, so you have the test result page, and this will be displayed by clicking on a build link on the history page of the Jenkins homepage. And on the test result page, the result of a test run can be examined. Jenkins displays the summary information about the tests executed and their total execution time. So you will have two categories. One will be all failed tests, which contains all the information about the failed tests, of course. And the other section would be all tests. So this will provide you brief information on the executed tests. For example, it will tell you about the package level results, so which will correspond to project suite runs. It will talk about class level results, which will talk about the projects in a project suite again. Then it will talk about test level results. So it will talk about the individual test level, what has exactly happened, whether it was a success or a failure, and round that particular test. So the history page basically displays the overall statistics of all the tests run. So in order to go to history page, you just need to go to the Jenkins home page, then click on history, which will take you to the right page. So the graph shows the execution time of the tests and also the ratio between the failed and the passed tests. To view the number of executed tests, you just need to click on show count, and it will tell you how many jobs or how many tests have been run so far for that job. And the table below will contain information on each build, test duration, the number of failed, skipped tests, and the total tests per build. All these information you will be able to see in that list, which is just below the graph. And if you want to see the complete test results in Jenkins, you just need to open the build page and choose test complete test results in the Jenkins menu. Sometimes it might not be there, so you just need to go ahead and install the right plugin. The plugin name is also the same. This will give you all the information about how many tests have failed, how many have passed. Then you can go and check what exactly those tests contains, and you can even go ahead and check the log files for those individual tests. If you want to, let's say, go and check and do a debugging why exactly your tests have failed and how do you want to make it pass. And this page displays a summary of complete test runs, information on the test runs, runtime, number of logged errors, warnings, etc. So depending on the results of the test, there are a couple of different statuses which are being displayed. So again, most of them are self-explanatory, but let's just take a quick look and understand. So the first one is fail to start. So of course, as the name suggests, the test did not start. So you can just click on the test name to see out and or check it out what exactly has happened, and then troubleshoot accordingly. The second status would be failed. So of course, it means that the test execution happened, but the test did not finish or it finished unsuccessfully. So it will be in red and there'll be some warning or error messages which should give you a clue. So you can again go to the logs and see what exactly has happened and try to find out what exactly was not correct and fix it. Warnings. So of course the tests will go ahead, they will finish off. This indicates that the tests have passed, but with some errors. So not exactly errors, more like warnings. And maybe you can just go ahead and read those warnings, and then based on that you can decide whether to do something about those warnings, or you can go ahead and ignore those warnings. And finally, you will have this pass status, which would of course mean that there was no problem, there was no warning, no error message, test has started, and maybe it took some time depending on how complex or big it is. And then end result was that the text execution passed successfully, which is what you would expect or you would desire every time when you run a test. Ignoring tests and code coverage. So there might be some situations where you actually want to go ahead and ignore the tests. So skip test cases are the deactivated test cases, and those test cases will be ignored by Jenkins. So you do have a way to deactivate the test cases if you need to do so. Jenkins will basically mark the skip tests as yellow in test details and in the test results trend. Now, skip tests are not as bad as test failures, but it is important that those tests should not be neglected. So if you want to skip some tests, you need to make sure why exactly you want to do that. You want to do some kind of intermittent testing or something like that. But eventually you would want to go ahead and activate those tests once again. If you have a test, there is a purpose for it, and you do want to run those tests against your code base. That's very important. Even if you are deactivating the tests, it should be only for a limited period or for a specific purpose. And yes, of course, a skipped test that remains skipped for too long is a bad smell. As I said, test is there for a reason. And you do want all these tests to run against your code in order to make sure that your code is robust and there is no bug in your code. There is no issue with the code. That's very important. So JUnit 4, the tests can be ignored using @ignore annotation. In test ng, the tests can be ignored using enabled property. In Maven, the test cases can be ignored using clean install. It's not exactly visible, but if you see here, this is the thing which you need to mention. Clean space install minus t skip tests equal to true. So that will basically tell Maven that the tests which are about to come should be ignored for now until say or tell otherwise. This is how it looks like. This is an example of test ng, and we can check out for others as well. So as you can see here, the first one, @ignore, is for JUnit 4, which is the example is given here, @ignore, and that is how you basically ignore in JUnit. So that brings us to the next topic, or the next subtopic rather, which is code coverage. So what exactly code coverage is all about? Code coverage gives us the details of which parts of our application was executed during the tests. So you can have thousands of lines of codes, 10,000 lines of codes in a single piece of code or in a single piece of software. Now, when you run the tests, it is very important to understand how much of that code is being used, whether you are able to cover, or let's say 20%, 30%, or 100% of the code. So the larger amount of area or large amount of code base you can cover, the better your tests will be, and the better your code, the more robust your code would be. So while this is not enough for quality testing, but it gives a good indication of the code that has not been tested. So code coverage analysis will slow down your build job. That's an important thing to understand, as it uses the CPU and memory intensive process extensively. So this is something which you need to keep in mind when you are putting a code coverage step in your CI/CD pipeline, because it is a resource intensive step. So you need to be prepared for that. So as a best practice, what you can do is you can run the code coverage metrics in a separate Jenkins build job to be run after your unit and integration tests are successful. So of course, there is no point in running your code coverage builds, first of all, before the tests, or if your unit test or integrations and tests have failed. So what typically people do is, as a best practice, there is one job for running all these unit and integration tests, and then there will be one job to run the code coverage metric to understand how much code has been covered. And the code coverage job will be triggered only on a successful completion of unit and integration tests. So there are code coverage tools available as open source, and a lot of them, as you can expect, they are supported in Jenkins through dedicated plugins. And of course, the most common name which you will hear, especially when it comes to Java-based platforms, is Cobertura. It is one of the most popular open source code coverage tools. So Cobertura is basically free Java code coverage reporting tool. It is based on something called JCoverage. Now, the main reason or the main aspect of a coverage tool is basically it shows you how many lines of code has been touched by your tests. In most cases, you will use Cobertura to see how good your tests are. And you can also use it to see how many lines of code are reached, or let's say to improve code that has been accessed or that is being accessed a lot. Cobertura will typically generate HTML or XML reports. When it started, it was meant to be used with AND, but it works pretty well with command line as well. It works with the plugins. It works with Maven and Eclipse both equally well. It started, as I said, it was actually meant for AND based builds, but it works equally well with Maven, and it works equally well if you're working on the command line as well. So it integrates well with both Maven and Jenkins, and it is an open source tool. And it works for both Java as well as Groove. So code coverage analysis, let's take a look how exactly it works. So there are 3 steps involved. So step 1 is modifies the application classes to keep a tally of the number of times each line of code has been executed, and it stores the data in a special data file. Step 2 is the tests are run against these instrumented code. And at the end of the tests, Cobertura will have a data file containing the number of times each line of code was executed during the tests. And step 3 would be when Cobertura will use this data to generate a report in a more usable format, such as XML or HTML. Now, important thing to understand is that Cobertura not only checks whether the piece of line or a piece of a snippet has been touched or not. If it has been touched, how many times it has been touched. That is also very important to understand. That actually gives you a lot more information or a lot more insight into how exactly your code is behaving. And based on that information or that insight, you can actually further enhance your code experience. Now, the installation part is again not exactly tricky. As you would expect, you need to go to Manage Jenkins page, then go to Manage Plugins. You will get to that screen where you have the plugin manager screen. You can just go and check it out first in the installed tab. If it is already installed, it will be under the install tab. If you don't find it there, just go to Available tab. In the filter keyword, just search for Cobertura and you will get the plugin, the right plugin. The first one, it just says Cobertura, and you can just go ahead and install that plugin in your Jenkins instance, and that's it, you're good to go. So the moment you put a check in the checkbox and press enter or click on install, Jenkins will download and install the plugin for you. Once the download is done, you will need to restart your Jenkins server. That's a one-time activity. So once you have restarted, you can either go ahead and do a server restart, or the easier way would be to restart your Jenkins service on the node on which you have installed it. So this is how it looks like. As I said, first you can just go ahead and check on installed, because many a times it will be installed by default. If it is not there, just come to the Available tab and search for Cobertura and install it. So Cobertura helps you in doing the code coverage, but there is one more aspect of reporting. So once the Cobertura plugin is installed, the code coverage reporting can be set up in your build jobs. And as we have spoken before, it's always a best practice to create separate build jobs for code coverage related activities, because it can actually slow down your system, slow down your Jenkins server, and especially hit you or affect you if you have other jobs running already. The important thing to understand is Jenkins is not doing any kind of code coverage analysis itself. You need to configure your build to produce the Cobertura coverage XML file. So how you do that? You actually go to the build section. Within this, as we have spoken, Cobertura is again one of the plugins within Maven. So you can just go to the Maven option, and under the goals section, you need to mention clean space Cobertura : Cobertura minus uppercase P space metrics. That's what you need to do. So once you do that, it has been configured, and then you can just go ahead and run the tests. So when you do the reporting, it'll actually provide the path to the Cobertura XML data. So there are several types of code coverage. The most important one is the line coverage, which counts the number of times any given line is executed during the automated tests. And then with the help of this plugin called Publish Cobertura Coverage Report, you can actually provide the path, and it will actually go ahead and publish the report over there. So Jenkins displays the code coverage reports on build homepage. The first time it produces a simple bar chart, and it will display a graph showing the code coverage trend over time. And this is how it looks like. So the next topic to understand is automated acceptance testing using JUnit. So acceptance test is an important part in many of the agile projects, both for verification and for communication. Acceptance testing, it's a level of software testing where a system is tested for acceptability. The main purpose of this test is to evaluate the system's compliance with the business requirements and assess whether it is acceptable for delivery or not. So basically, this is the test which you do typically at the end. When you do this test, that is basically to check whether your software is field ready or not. Usually, you will do black box testing method, which is the most common one in acceptance testing. And again, this kind of testing does not allow or does not follow a strict procedure. It's more like ad hoc when you do it. And as I said, this is the fourth and the last level of software testing performed. Once you have all the other kinds of testing like integration, regression, smoke testing, all these things are done already. So you do this acceptance test at the end. Again, what happens? Who performs it? So there are two levels again. So what happens? You have something called internal acceptance testing, which is also known as alpha testing, and which is typically performed by the members of the organization that developed the software. However, they are not directly involved in the project. So that's the alpha testing. Then you have something called external acceptance testing. So these are the people typically who are not part of the organization. And in this case, what happens? We have something called user acceptance testing, which is also known as beta testing. It is performed by the end users of the software. So in this case, they can be the customers themselves or the customer's customers. So that again varies depending on the project and the software which you have. So it performs similar role to integration tests. It primarily focuses on communication. So communication between all the stakeholders or among all the stakeholders, basically demonstrating to non-developers precisely the status of the project. So this is how you inform all these stakeholders other than the technical staff that what exactly this project is at which level, and what should be expected. The main aim is to demonstrate that the application effectively does what it is expected to do, or what it is desired to do, what you have written it for. And of course, it should not be mixed with the developer focused tests. So all the other tests, they should be completed first, and then you go ahead with the acceptance test. So that was about the acceptance test. Now again, acceptance tests can be automated using tools such as JUnit, and you need to automate it if you want to create a full-fledged and effective CI/CD pipeline. So there's a requirement to use a behavior-driven development framework for this when you're using JUnit and when you're using acceptance test, because both of them, when you talk about behavior-driven development and when you talk about acceptance test, both of them are actually focused on how your software or how your application is behaving in real time and how close it is to the end user's requirement. So behavior-driven development tools used for automated acceptance tests typically generate HTML reports with a specific layout that is well suited to non-developers. They also produce JUnit compatible reports that can be understood directly by Jenkins. Acceptance tests should be displayed separately from the other more conventional automated tests. So as we have spoken already. So you should, all the other tests such as unit testing, regression tests, integration tests, all of them should be treated separately, and the acceptance test should be treated separately. That's what we mean by this statement. If you're using the same testing framework as your normal tests, such as, let's say you're using same framework for acceptance test as well as your integration and regression testing. So you need to make sure they are executed in a dedicated build job so that non-developers can view them and concentrate on the business-focused tests without being distracted by low-level or technical ones. So since acceptance test is more focused towards the stakeholders, towards the customers, and towards the more non-tech audience, it is very important to have a separate channel for that. They would not be interested in your code and what exactly is wrong with the code, if there was any bug or something. They are more interested in how the application is behaving in real time in the form of a GUI. So JUnit with Jenkins, what happens is you trigger a build. It goes to Maven as the build tool. Maven again triggers JUnit, and then it might be using Selenium as a testing framework, which will be managing all these things for you. So once acceptance test is done, typically your software will be deployed or it will be ready to be deployed. That is where the performance testing comes into picture. So automated performance testing is used to check how an application deals with, let's say, an increasing number of users, or if you want to check how an application responds to the requests with a number of simultaneous users. So basically you're doing the stress testing. Let's say your general traffic is 500 or maybe 50 hits per second. What will happen or how your application will behave if it goes, let's say, 1000 units per second or 10,000 units per second? How exactly it is going to behave? Will it crash or will it be able to handle it properly? What kind of a scaling mechanisms you would need if that is failing? So these kind of things will come into picture when you talk about performance testing. And of course, Apache JMeter is one of the most popular tools, especially with Java platform when it comes to doing automated performance testing. So it is undertaken at the end of the project or when things start to go wrong. So typically you do it after the deployment and after the application has already started catering to the end users. So you typically deal with the performance issues, let's say some sort of bug, some sort of feature which is not behaving in the right manner. So all those things you would talk about when you talk about performance test. So the later on in the process they are detected, the more costly they are to fix. So this is something where we talk about the technical debt aspect for software development. So whatever problems are there in your software or in your application, you want to fix them as soon as possible. The more they are inside the system, the higher the technical debt will be and the higher the cost involved will be to remove them. So it's always a good idea to automate performance and load testing so that you can spot any areas of degrading performance before it is too late. So we always talk about shifting left when we talk about DevOps. So you don't wait for your application to degrade, rather you proactively test your application with simulations of multiple users and multiple hits. You increase the stress on your application and see how it behaves. So that way you are acting, you're doing a proactive measure, you are taking it proactively and you're not waiting for your application to go wrong or go down. Now talking about JMeter, it is a popular open source performance and load testing tool. It simulates load on your application as we have spoken. So from 50 to 100 to 200 to 1000 to 10,000. So you can actually control that how exactly you want to work with. So, and you measure the response time as the number of simulated users and requests increase. So you can put a immediate increase, like some kind of a very sudden spike, or you can have simulated in an increasing fashion. So 50 to 100, then 200, then 500 and 1000, like that, in order to understand how your application is behaving and till what level your application is comfortable and from which level it starts breaking and it starts behaving weird and it starts lagging. And of course, it also simulates the actions of a browser or client application, whichever is applicable. So JMeter, you need to configure various real-time actions, so multiple requests to be posted to an application, random conditions, loops, pauses, and other variations. So JMeter runs on a Swing application in which you can configure your test scripts, and you have XML files and JSON files through which you work, and then you have a test case repository, both of which basically will report to Apache JMeter. They will have access to Apache and they will be put on JMeter, and then from there the test will be run and the reports will be published. So the build script needs to be configured to handle JMeter. To set up a performance testing build in Jenkins, first of all, you need to make sure that this is installed, and you need to make sure that it understands the JMeter logs and generates the statistics. So you just need to click on this link, or if it is not there, just go ahead and search for the plugin called Performance, and then it will help you in working with JMeter plugin. So configure the build jobs to run the tests. You can go to the build section. You can click on under the root section, root POM, you can mention pom.xml as always. When it comes to POM goals, you can mention clean verify -p performance. Then you can give the Maven options with regards to memory and heap size and those sort of things. And to set up the reporting, you need to choose this option called Publish Performance Test Result Reports. This will be available under Post Build Actions, and you need to provide the path to JMeter test results. It should look something like this. So once you have done and once you build the job, the performance plugin will produce graphs and it will keep a track of overall response times, number of errors, and things like that. And this is how a typical application performance graph will look like once you have done a couple of builds. So let's take a sample application. What we will do is we'll go ahead with a demo to configure a job to set the test reports and Maven based builds and running Cobertura based code coverage on them. So these are the steps involved. First of all, you create a new job, you select the projects with the help of git location, then you configure it further, configure test results, configure the job to run code coverage using Cobertura, and then run the code coverage and run all the tests. So these steps are what we will be following from now onwards. It is available in the demo document for this particular module. So you will have, which is under the presentation, you can just go and take a look at it, and then you can follow the instructions and along with the screenshots which is there on that link. So before we proceed, what we need to do is we need to make sure a couple of plugins installed for us, and those plugins would be disk usage. We will not use Windows Linux because we are not working with Windows based machines. Then we need to use static analysis utilities is one such plugin. One more which we need to make sure is find bugs. We need to make sure code coverage API is installed. Of course, Cobertura has to be there. JUnit plugin should be there, and then test complete. So let's take a look whether we have these plugins installed already on our Jenkins instance or not. So we'll go to Manage Jenkins. We go to Manage Plugins. Click on Installed. Let's check if we have everything or not. So let's start with the disk usage. So disk usage plugin is installed, as we can see. So we are good here. Let's check. Static analysis utilities is also installed, as we can see here. Let's check. Find bugs plugin is also here already. Code coverage, let's see if we have. So as you can see here, code coverage API plugin is installed. We have Cobertura plugin which is also installed. Then let's take a look at if we have JUnit plugin installed or not. So we have JUnit plugin as well as test complete plugin. Both of them are installed. We have JUnit as well, already installed on our Jenkins instance. So when it comes to plugins, we are good here. We don't need to install anything additional. We can go ahead and start with our job configuration. So I click on new item. Let's say I give it as automate testing. Click on OK to create this job for us. So once we are on the configuration page, first thing we need to mention is the repository URL. So in our case, github.com/edureka-devops/jenkins-demo.git is a repository which we are interested in. Then we need to go ahead and create a build step. So I'll use invoke top level Maven targets. I'll use as local Maven. I have two different Mavens configured. So local Maven is the one where Maven is pre-installed on my system already. So, and I think it is Maven 3.5. Then I need to mention the goal as verify, and in this case, if I go here, this is the repository which we are working with, and as you can see here, there is no pom.xml here. Rather, pom.xml file should be inside Maven project. So we need to be careful while giving this location. So when we are writing the location for pom.xml, we need to copy this location basically. So I'll copy the name so that I don't do any mistakes, and then within that I can mention pom.xml. So that will be for Maven to verify. The next thing would be for Cobertura, and again for that I can create another Maven step, again local Maven, but this time the goal would be different. What I will do is Cobertura metrics, and once again I will simply write pom.xml, and once this is done, this will generate the reports. This will basically do the testing, and what we are interested now in is to publish the results. So for that I need to use, first thing would be to use the JUnit test results. So publish JUnit test result report. This is the one I'm going to use. Here basically I just need to mention my location of the XML file where I want to keep it. So I'll just give a random location. Let's say I make it as Maven project master star.xml. That's it. And then the last thing would be to publish the Cobertura coverage report. And once again, I need to mention where it is going. So there's a specific syntax which you need to use, Cobertura coverage.xml. So now we can go ahead and save this, and let's build it as well. Let's see if all goes well. So I clicked on build now, and it has started our first build. Let's go to the console output and watch things in action. Now it is going to take maybe about 4 to 5 minutes. So what I'm going to do is I'm going to pause my video and we will start again once it is done. As you can see here, the test has been completed, and the job, basically the build of this job, has been completed successfully. And it took about 2.5 minutes to complete everything. Starts with the simple multi-module build and goes on to download some Maven based plugins. Starts with the tests, as you can see here, running the artifactory.test.apptest. Again, so it goes on, continues, again one more test. So this time there is one test, no failures, no errors, all good. Again one more test. So it keeps on doing. In between it gives you some warnings as well. For now, for our purpose, we can actually go ahead and ignore these warnings. Should not be a big problem. But if it is a production environment, then you need to at least read it and see if it is relevant for you or not. So as you can see here, then it starts with the building simple multi-module, build snapshot 3.7, continues, and at each step it gives you all the information about what is going on, what exactly the tests are running. As you can see, Cobertura is being run, JUnit is running, so all those tests are running here, and they are giving you the results one by one. And as you can see here, finally it tells me that the build is successful, and with of course a couple of warnings. It publishes Cobertura coverage report, and it is publishing Cobertura coverage results as well. So that was about the demo. So we have come to an end of this module, and what we have learned so far is the concept of automated testing. We spoke about automated unit and integration testing, spoke about test reports in Jenkins, then we spoke about how to display the test results, to ignore the tests. Finally, we spoke about two tools called JUnit and JMeter. So JUnit we used for acceptance testing, and JMeter we used for performance testing. Thank you for watching, and see you in the next video.